Semigraph is such a concept. So now let's look on to some applications of semigraphs in neurology of mental illness, anxiety. Abstract. Semigraph is such a conception of a graph and it is similar to a graph when drawn in a plane. A semigraph contains more than two vertices. As the graph theory can abstract anything, the semigraph can also abstract anything which has two edges at the most one common vertex according to the definition. Besides in medical field or human neurology, semigraph can be very useful. Human body works with the functions of brain and nervous system. The human body suffers from different types of diseases which may affect the human brain too and it may respond to the diseases. The research paper, Application of Semigraphs and Directed Graph in Neurology of Mental Illness, Anxiety, represents how semigraph and directed graph can be used to know the diseases that affect the human brain and how it may respond to it. Introduction. The notion of semigraph is a generalization of that of a graph. While generalizing a structure, one naturally looks for one in which every concept in the structure has a natural generalization. Semigraph is such a natural generalization of a graph and it resembles a graph when drawn in a plane. Semigraph is similar to a graph, but it allows for many new important or meaningful outcomes that may or may not be possible with a graph theory. The human brain functions similar to a computer CPU. It carries all informations received from the human body senses, sends messages back to the human body and begins to function. As a disease affects the human body or the organs, diseases can also affect the human brain, which is referred to as mental disorder or mental illness. Most commonly, the person suffers from anxiety, which affects the human brain and results in mentally depressed person. Most commonly, the person suffers from anxiety, which affects the human brain and results in mentally depressed person. It is crucial to know and comprehend quickly how this sickness or condition might affect the human brain and nervous system, given that it is a widespread disorder or illness among people worldwide. It is kind of fascinating how the medical field area interacts with semigraph and directed graph theory. Knowing that you could need it in future is crucial in today's society. To learn about a condition or the relationship between an illness and another in your neurology or any other body system, you don't have to work in medical field. The objectives of this work are: first, create a graphical representation of the disease analysis in medical field, and then apply semigraph and directed graph in modeling interactions between objects, and finally to use graph theory to discover the process of neurology of the brain responding to the diseases. Preliminary definitions. Graph: a graph h equal to v comma e consists of a set of objects h v1 v2 etc called vertices and another set e1 e2 etc whose elements are called edges. Example of a graph: directed graph. A directed graph is made up of an ordered collection of x pairs of distinct points and a finitely non-empty set v of points. Figure 2 is an example of a directed graph. 1-ൽ നിന്ന് 2-ലേക്ക്, 3-ൽ നിന്ന് 2-ലേക്ക്, 1-ൽ നിന്ന് 3-ലേക്ക്, 3-ൽ നിന്ന് 4-ലേക്ക്, 4-ൽ നിന്ന് 3-ലേക്ക്. Semigraph. A semigraph G is a pair of V, X, where V is a non-empty set whose elements are called vertices of G, and X is a set of n tuples called the edges of G of distinct vertices. For various n greater than or equal to 2 satisfying the following conditions, any two edges have at the most one vertex in common. Two edges u1, u2, etc. un and v1, v2, etc. vm are considered to be equal if and only if m is equal to n, either ui is equal to vi for all I, or ui is equal to vn minus 1 plus 1 minus I plus 1 for all I. An edge E is represented by a simple open Jordan curve which is drawn as a straight line whose endpoints are called n vertices of the edge E and m vertices of edge E, each of which is not an m vertex of any other edge of semigraph. മനസ്സിലായില്ല. Denoted by small circles placed on the curve in between the n vertices. The n vertices of edge that are not m vertices are represented by thick dots, and an m vertex of an edge E is an n vertex of an edge E, and an m vertex we will draw a small tangent. Okay. Example 1. Let G equal to V comma X be a semigraph, then the edges of the semigraph in figure 3 are V0, V1, V2, V2, etc. 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 ഏതൊക്കെ edges? V0, V1, V2. V0, V1, V2 is an edge. V2, V6, V7, V8. V2, V6, V7, V8 is another edge. V1, V3, V4. V1, V3, V4 is an edge. V4, V5 is another edge. And V5, V6 is another edge. V1 and V6 are middle vertices of this edge and this edge, and the end vertices of this edge and this edge. So there is a small tangent. A dendroid. A dendroid is a connected semigraph without strong cycles. A forest in a semigraph and a forest in a semigraph in which every component is a dendroid. Pendant dendroid. A pendant dendroid is a dendroid with a pendant on each edge. For example, figure 4 is a pendant dendroid. ഓക്കെ എല്ലാ എഡ്ജിൻ്റെ അവസാനം ഒരു പെൻഡൻറ്റിലാണ്. Application of semigraph in neurology of a brain. Structure of a brain. In humans, the structure of a brain, figure 5. Figure 5, എവിടെ? Figure 5 structure of a brain. Okay. Which has 100 billion of nervous systems, controls every aspect of the function. Our emotions, including happiness, stress, and depression, as well as any diseases, are tied to or controlled by the brain. As I have already discussed how the brain operates and manages the human body, similar to how the CPU manages the computer, similar to anxiety, the amygdala is a component of the brain that has a neural system. Amygdala is afraid of uncertainty. The brain's amygdala reacts to any type of human emotion, including stress and worry. The brain, let the set of vertices in a semigraph H be all the name vertex V, comma E, where H is equal to V1, V2, V3, V4, V5, V6, V7, V8, V9, V10, and the edges of the semigraph H are V1, V2, V2, V3, V4, V1, V3, V1, V4. This meets the requirement of the semigraph. Forebrain, midbrain. Forebrain, midbrain, hindbrain. Forebrain, midbrain, hindbrain. What is DC? Cerebrum. Okay. This demonstrates that, unlike the brain structure, the brain structure diagram below figure 6, which is complicated, the structure of the area of brain associated with anxiety can be presented and illustrated simply. The major components of a brain's anatomy are a little more difficult for a non-medical department to comprehend. Next, observe figure 7 and figure 8 of a forebrain. Figure 7 and figure 8. Okay. Which is divided into two portions, the telencephalon and diencephalon. T- Telencephalon and diencephalon. Each of which has a unique. How to read this, bro? Copy. Spell. Telencephalon. Telencephalon. Cephalon. Telencephalon. 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 Telencephalon and diencephalon. Diencephalon. Telencephalon. And diencephalon. Okay. So let's go back. which is divided into two portions, telencephalon and diencephalon. Telencephalon and diencephalon, each of which has a unique set of connecting structures and functions. Instead of observing the other portion, let us observe the portions that contains the amygdala, the portion that reacts to anxiety. Amygdala, uncertainty and anxiety. Applications of dendroid in Alzheimer's disease. The most prevalent kind of dementia, Alzheimer's disease, primarily affects elderly people. Alois Alzheimer's in 1906 created the disease. Alzheimer's is a neurological disease, figure 9 and figure 10. Figure 9 and figure 10. That results in brain shrinkage and loss of brain cells. Brain shrinkage and loss of brain cells. Let us now discuss how Alzheimer's disease impacts the human brain using a pendant dendroid semigraph. Take a note of figure 11. Healthy brain is depicted in the first graph. Healthy brain is followed by Alzheimer's disease's attempt to damage memory related neurons. Alzheimer's disease's attempt to damage memory. And the neurons and the remainder of the vertex associated with the neurons, including the entorhinal and hippocampus, are affected. Entorhinal, entorhinal and hippocampus. The cerebral cortex is the last area affected when it affects those three vertex. Cerebral cortex. ഏതിനൊക്കെ affect ചെയ്യുന്നത്? The given figure 12 is the pendant dendroid semigraph, which can be considered as normal brain of a healthy person. The triangle shapes of the figure represent neurons of a healthy person's brain. Assume it as V1. The vertex EC represents the entorhinal cortex. Consider this as V2. HC represents the vertex V3. HC represents the vertex V3. So this is V1. Sorry, V1 is HC and V3. CC represents V4. So V2, V3, V4. So this is V1. Now from figure 13, consider a white vertex entering, this is not white, entering the neurons, and assume it as an Alzheimer's disease which is trying to get contacted with the memory connected with the number of neurons. From figure 14, observe the triangle shape colored completely, while we can consider as totally affected by Alzheimer's disease. In this way, we can figure out easily how Alzheimer's disease can affect the parts of a healthy person's brain and know the way for treatment of a patient without observing to a critical structure of a brain. Directed graph on amygdala responding to anxiety. Amygdala is the part of the human brain that has a central role in anxiety responses to stress involved situations. During the response of the amygdala to anxiety, their activation influences anxiogenic effects while their inactivation causes anxiolytic effects. Also, neurotransmitter and stress mediators have a role in amygdala nuclei can regulate the character of anxiety. All human beings go through anxiety in some cases. Every person has faced it or facing it. It is a psychological response that we face in our everyday life. Anxiety is so common that it is one of the most common symptoms of neurological diseases. In this section, we will try to describe the connections of neurons of a brain associated with the anxiety with the help of directed graph. It is a little difficult to understand the process with the help of general diagram given below. Directed graph of a brain. Now let us represent it by the directed graph. Observe the graph below. Figure 16 is the graph of a response of amygdala to anxiety when the patient is given an anxiogenic projection. Here, BLA represents basolateral amygdala, considered as vertex V1, which is directed to MPFC. MPFC represents medial prefrontal cortex. Again, HPC represents hippocampus directed to BLA and BLA. And BLA, CEA, MEA are directed to BNST. Bed nucleus of stria terminalis, and BNST is directed to VTA, ventral tegmental area, also to add BNST, anti-dorsal BNST. Next, let us observe the other figure 17, which determines the directed graph of an anxiolytic projection process of amygdala responding to anxiety. Anxiolytic എന്നായിരുന്നു? Inactivation. Where each named vertex is directed to each other vertex creating an edge. അപ്പോൾ ആദ്യം ഇവിടെ നിന്ന് ഇങ്ങോട്ട് പോവും, ഇവിടെ നിന്ന് ഇങ്ങോട്ടും ഉണ്ട്, പിന്നെ ഇവിടെ നിന്ന് ഇങ്ങോട്ടേക്ക്, ഇവിടെ നിന്ന് ഇങ്ങോട്ടേക്ക്. Next, observe figure 18, where each vertex is directed to another vertex with an edge having a transmitter process of amygdala responding to anxiety. Here, BNST vertex is directed to LHA and VTA, and MPFC is directed to BLA, and BLA is directed to BNST. As mentioned, all vertices V are neurons attached to amygdala, and directed lines are edges connecting to other vertexes, and it takes part during the process while amygdala responds to anxiety. So conclusion, in this research work, we initiated application of both semigraph and directed graph theory in neurology of human brain, and also in a disease of mental disorder or an illness with different types of tools in different types of ways. We also tried to show the critical figure can be shown in a simpler and easy way to make understand in a proper and easy way to the people with a graph or a semigraph.